distance is more, then dipole moment is more. If charge is more, then also dipole moment is more. Because dipole moment is directly proportional to charge and distance. Clear? If any molecule contains more charge, dipole moment is more. Or in a molecule, if distance between the ions is more, then also dipole moment is more. Okay, based on the given questions, we will decide whether we have to consider charge or distance. Here also we have exceptional cases. Okay, coming to the units of dipole moment. Dipole moment is measured in dBi. dBi. 1 dBi is equal to 10 to the power of minus 18 ESU centimeter. Yes, electrostatic unit. Electrostatic unit. That is 1 dBi value. 1 dBi. dBi is the unit of dipole moment. And 1 dBi is equal to 10 to the power of minus 18 ESU centimeter. ESU stands for electrostatic unit. Charge centimeter for the distance. You can write units like this also. Coulomb meter. Coulomb meter. Unit for charge is coulomb. For distance, meter. Coulomb meter. Another unit, coulomb meter. Okay. See, why I given this formula? Yesterday we went through general explanation, general definitions, right? But now we are going to discuss one important example. For that, we need charge into distance relation. Okay. See that example. Already you know this example. In alkyl halides, I explained. Try this. You know already. Yes. Important example, also important example in chemical bond. Exceptional case. Generally, 99% cases, if electronegativity is more, then dipole moment is more. For example, if I give this question, H2O and NH3, which is having more dipole moment, means obviously H2O only, because oxygen is more electronegative, so dipole moment is more for H2O. But here we should not apply this logic. Electronegativity concept exceptional. We have only few exceptional cases, so you have to remember that exceptional cases. Any idea? In alkyl halides, I already explained. For 1 and 2, yeah. Why? What is the reason? Yeah. Yeah. In 1 and 2, we consider distance. Distance. Distance is taken into consideration. Distance is considered. In the remaining, we consider charge. Charge. What is the relation? U is equal to Q into charge into distance. What we are considering between these two? We are considering distance. Distance. Which is having more distance. Carbon chlorine bond is more. So CH3Cl is having more dipole moment. More dipole moment. So what is dipole moment order? Mu order. 2 greater than 1 greater than 3 greater than 4. Here don't apply electronegativity concept. Only one exceptional case. In remaining, generally, if you get like this H2, NH3, CH4, then apply electronegativity concept. Okay. Next, dipole moment in disubstituted benzene. Mu in disubstituted benzene. Disubstituted. Disubstituted benzene. Are though disubstituted, meta disubstituted, and para disubstituted. Para disubstituted benzene. What is the general definition? What is dipole moment? Moment in bond is called as dipole moment. In generally, para disubstituted benzene dipole moment is 0. Why? because this A is pulling in the upward direction. This A is pulling in the upward direction and this A is pulling in the downward direction. So net dipole moment is 0. Are you getting? Online students. Disubstituted benzenes, in generally, exceptional cases are there. In generally, para disubstituted benzene dipole moment is 0 because net moment will be cancelled. Cancelled. If we give labeling ABC, ABC, what is the dipole moment order? A is having, since ortho disubstituted benzene is having more dipole moment than meta disubstituted than para disubstituted. Here dipole moment is 0, mu is equal to 0. Okay, exceptional cases are there. We will discuss that exceptional cases also. Let us take some examples. Can we give its name? Anybody? What is the name of this compound? Give numbering. Give numbering and say the name. Give numbering. Orthodichlorobenzene, orthodichlorobenzene, metadichlorobenzene, and paradichlorobenzene. Can we call it as 1,2-dichlorobenzene? Is there any mistake? 1,2-dichlorobenzene. This is 1, 2, 3, 4, 5, 6. 1,2-dichlorobenzene. 1,2-dichlorobenzene. 1,3-dichlorobenzene or metadichlorobenzene. And 1,4-dichlorobenzene or paradichlorobenzene. Which is having 0 dipole moment. Paradichlorobenzene or 1,4-dichlorobenzene. So overall dipole moment order A greater than A, B greater than. Although dichlorobenzene is having more dipole moment. Okay. Now coming to the exceptional case. Exceptional. In generally, para disubstituted benzene or 1,4 disubstituted benzene dipole moment is 0 in most of the cases, 99% cases. But see exceptional case. This is para disubstituted only. This is also para disubstituted only. But these two compounds dipole moment is not equal to 0. Mu not equal to 0 here also, mu not equal to 0. Because this OH group is having its own dipole moment. This OH group also having its own dipole moment. So net dipole moment should not be 0. What is the meaning of own dipole moment? Once look at this, all of you. Observe OH bond. Observe OH bond. In OH bond, dipole moment is present or not? Yes or no? So with respect to this direction, dipole moment will be cancelled. But internally, in OH group, dipole moment is present. Okay, internally, in OH group, dipole moment is present. With respect to this position, dipole moment is 0, but it is having its own individual dipole moment. Here also SH. SH bond is having dipole moment, its own dipole moment. SH group is having its own dipole moment. OH group is having its own dipole moment. But when we see in this position, dipole moment is 0. But individually, if we observe, it is having it is having dipole moment order. Okay, these two are the exceptional cases, OH and SH. Next, mu in cis and trans isomers. Dipole moment in cis and trans isomers. Mu is equal to 0 for trans. This is trans compound. This is cis compound. Trans compound dipole moment mu is equal to 0. Cis compound dipole moment is not equal to 0. Which is polar and which is non-polar? Tell me. Cis and trans. This is polar. Non-polar. Give an example. Give an example first. What is its name? What is its name? Online students. What is its name? No. Cis or trans? Which form this is? Which form this is? Trans. Trans to butene. Trans to butene. Trans to butene. Trans to butene mu is equal to 0. Cis to butene mu not equal to 0. Keep it in percentage of ionic character. See, by using dipole moment data, we can find the percentage of ionic character. Keep heading. Percentage of ionic character. Percentage. Percentage of ionic character. Percentage of ionic character is equal to mu observed dipole moment by mu theoretical dipole moment into 100. During the calculation of percentage of ionic character, we take the charge of the electron. So you write the value of charge C is equal to, in atomic structure, what is the charge on the electron? Charge on the particle. Negative particle electron, positive particle proton. So what is the charge on the particle? 1.602 into 10 to the power of minus 19 coulombs. We use this actually. Okay. Observed dipole moment by theoretical dipole moment into 100 into 100. How to find theoretical dipole moment? Mu theoretical. Mu theoretical is equal to charge into distance. Mu theoretical is equal to charge into distance. Here, this is the charge value 1.6 into 10 power minus 19 coulombs. Okay, distance will be given to you. Here, see, charge nothing but this one only. Once give the arrow. Online students, are you ready? All of you. See the definition of hydrogen bonding. See, under this topic, we discuss definition, types of hydrogen bonding, in which state of matter more hydrogen bonding is present, when strength of hydrogen bonding is more, and examples of intermolecular and intramolecular hydrogen bonding, and consequences of consequences of hydrogen bonding. Okay. Definition: weak electrostatic force of attraction. Weak electrostatic force of attraction attraction between hydrogen. I'm giving one bracket. I'll tell you what we have to write in that bracket. Weak electrostatic force of attraction between hydrogen and and more electronegative atom. More electronegative atom. Where electronegative atoms are phone call. Chlorine, oxygen, nitrogen. One code, phone call code. When hydrogen is present on these atoms, then only it participates in hydrogen bonding. Remember that. And coming to this bracket, what we have to write in this bracket? Why I particularly highlighting this? Because it came in the JEE mains. Okay. When hydrogen atom participate in the hydrogen bonding, when it is present on the more electronegative atom. First condition for the hydrogen bonding is hydrogen should be present on more electronegative atom. For example, if hydrogen is present on less electronegative atom, then it would participate in hydrogen bonding, right? Okay. See, okay, hydrogen should be present on the more electronegative atom only. Between more electronegative atom and hydrogen, covalent bond should be present. See, weak electrostatic force of attraction between hydrogen, see, which should be in covalent bonding. It should be in covalent bonding with more electronegative atom. More electronegative atom. Okay. Weak electrostatic force of attraction between hydrogen and more electronegative atom. This hydrogen and this more electronegative atom both should be held by covalent bonding. That is the condition. That is the condition. Right. Definition of hydrogen bonding is the weak electrostatic force of attraction between hydrogen and the more electronegative atom. This is a simple definition. Weak electrostatic force of attraction. See the example. This is more electronegative atom. Fluorine is more electronegative atom. This is hydrogen. Observe, now we are analyzing between these two whether hydrogen bonding will take place or not. Look at this. We have three examples here. Weak electrostatic force of attraction between hydrogen and more electronegative atom is called as hydrogen bonding. Weak electrostatic force of attraction between hydrogen and more electronegative atom. This is called hydrogen bonding. Hydrogen bond, H bonding. Okay. Here also, weak electrostatic force of attraction between hydrogen and more electronegative atom. Here, can I write hydrogen bonding? Can I write? Yes or no? Here, hydrogen is present on more electronegative atom. Here, hydrogen is present on more electronegative atom. But here, hydrogen is not present on more electronegative atom. Of course, hydrogen is present and more electronegative fluorine is present. But here, hydrogen is present on less electronegative atom, carbon. So here, hydrogen bonding do not take place. No hydrogen bonding here. No H bonding. So what is the condition for hydrogen bonding? Hydrogen should be present and fluorine or any other more electronegative atom should be present. But hydrogen is present on which atom? Another more electronegative atom. For hydrogen bonding, we need hydrogen and we need more electronegative atom. At the same time, observe whether hydrogen is present on another more electronegative atom or not. That is very, very important. So between CH4 and HFO, hydrogen bonding do not take place. Clear? So very, very important. If hydrogen is present on another more electronegative atom, that hydrogen only participate in hydrogen bonding. Okay? Online students, did you get this? Let us give some organic touch for hydrogen bond. Okay. Say hydrogen fluoride liquid. Hydrogen fluoride. I am giving you a beaker. In that HF is present. Hydrofluoric acid. You know hydrofluoric acid liquid. If you pour hydrofluoric acid on the glass, it will melt. Glass will melt in hydrofluoric acid. It is a liquid, hydrofluoric acid. It is used to draw something on the glasses. Hydrofluoric acid liquid. Imagine a beaker containing hydrofluoric acid. Now I am asking you one question. In HF, hydrogen bonding is present or not? That is my question. What I am doing, I am giving you HF liquid to you, HF beaker to you. And I am asking, in this hydrogen bonding is present or not? Then what you will say? Hydrogen fluoride liquid contains many HF molecules, right? You know, if you take one 10 ml water, in the 10 ml water, infinite water molecules are present. Water only, we are calling water only, but inside it, so many H2O molecules are present. This is hydrogen fluoride liquid, but inside, so many HF molecules are present. Between one HF molecule and another HF molecule, hydrogen bonding will take place. So in HF, hydrogen bonding is present because hydrogen is present, fluorine is present, and hydrogen is present on another more electronegative atom. That is the condition. See, primary condition is hydrogen should be present and more electronegative should be present. Yes, primary condition is satisfied. What is secondary condition? Hydrogen should present on another more electronegative atom. Fluorine is another more electronegative. So hydrogen bonding is possible. Right. In HF, hydrogen fluoride, hydrogen bonding is possible. Why I am explaining this? Uh, Probability is there to get these type of question. In which of the following hydrogen bonding is not possible? Clear? Now, dimethyl ether, organic. Dimethyl ether. In another beaker, I am giving you dimethyl ether. In dimethyl ether, hydrogen bonding is present or not? Look at this. Dimethyl ether structure. Dimethyl ether. Already nomenclature is over for you. Dimethyl ether. CH3O, CH3. Dimethyl ether. This is one dimethyl ether molecule. This is another dimethyl ether molecule. Dimethyl ether. You tell me, in dimethyl ether, hydrogen bonding is present or not? In dimethyl ether, hydrogen bonding is present or not? Online students? More electronegative atom is present, oxygen is present, and hydrogen also present, na? Hydrogen also present, but hydrogen is present on what? Carbon, less electronegative. So dimethyl ether do not show hydrogen bonding. Hydrogen bonding, no hydrogen bonding. No hydrogen bonding. No H bonding example. Dimethyl ether. Acetone. Acetone. What is acetone? CH3. C double bond O. CH3. In acetone, more electronegative atom is present, but hydrogen is not present on more electronegative. Hydrogen is present on carbon. Not possible. Hydrogen bonding. Dimethyl ether. Acetone. Dimethyl sulfoxide. DMSO. Dimethyl sulfoxide. Generally, it is abbreviated as DMSO. Dimethyl sulfoxide. Do not contain hydrogen bonding. Oxygen is present, but hydrogen is not present on the more electronegative atom. Okay. Next. Extent of hydrogen bond. First, I will cover some dry theory-based topics. Then we will come to model question because You can remember easily in which of the following intramolecular hydrogen bondings are present, but you will forget these type of theory points. Okay, extent of hydrogen bond, extent or strength. It is also called as strength of hydrogen bond, strength of hydrogen bonding. Strength of hydrogen bonding is directly proportional to strength of H bonding is directly proportional to electronegativity. Strength is directly proportional to electronegativity. One example, in which of the following hydrogen bonding is present? Dot 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 HF. In which of the following strong hydrogen bonding is present? I'm taking water. Dot 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 HF. OH. In which more strength is present? Hydrogen bonding strength. Yes, because fluorine is more electronegative. Strength of hydrogen bonding is directly proportional to electronegativity. Main questions you can remember, but these small subtopics you will forget. That's why first I am covering that only. Next, you tell me ice, ice, water, and water vapor. Water vapor. Formula is same only. H2O, H2O, H2O. Okay. In which more strong hydrogen bonding is present. Strength of hydrogen bonding is more in which state of matter hydrogen bonding will be more. Ice means solid or liquid? Solid. Solid, liquid and gas. Strength of hydrogen bond. Solid. For one substance in its solid state, extent of hydrogen bonding is more. Solid is greater than liquid, and in gas very less. But write the order. So for water in its solid state means ice. In ice, extent of hydrogen bonding or strength of hydrogen bonding is more. Next, type of hydrogen bonding. Types of hydrogen bonding. Question coming area. Types of hydrogen bonding. Hydrogen bonding is classified into two types. What are the types? Intermolecular, intramolecular, intermolecular, intermolecular hydrogen bonding, and intramolecular, inter and intramolecular, intramolecular, inter, inter means look at this. Intermediate is how many years? Intermediate course, 2 years. So, if hydrogen bonding takes place in between two molecules, that is called as intermolecular hydrogen bonding. Remember, like intermediate is 2 years. So, intermolecular hydrogen bonding is hydrogen bonding takes place in between two molecules. The two molecules may be same or different molecules. Hydrogen bonding takes place in between two molecules. The two molecules very important. The two molecules may be same or different molecules. Then it is called as intermolecular hydrogen bonding. Consequences are very important. Okay. Once look at this, all of you, one example, HF, HF and H2O. Your molecules are same or different? Tell me, same or different molecules? Different. What I given? Same or different? So this is one molecule, this is one molecule, two molecules, intermediate, 2 years, two molecules. So intermolecular hydrogen bonding. And look at this, another example. Can I take like this? Here ammonia molecule, here also ammonia molecule. Sorry, right, hydrogen this side. Both are ammonia only, no? NH3, NH3. Here, same molecules. We are taking same molecules. Same molecules. See here, same or different molecules. Now, very, very important. Answer this question. I am giving you ammonia liquid to you. In ammonia liquid, which type of hydrogen bonding is present? Inter or intra? In ammonia liquid, so many ammonia molecules are present. Ammonia, ammonia. In between two, hydrogen bonding takes place. That is intermolecular. I am giving water to you. In water, which type of hydrogen bonding is present? This is one water molecule. This is one water molecule. Two molecules. Inter or intra? Inter. What is definition of intermolecular hydrogen bonding? Between two. May be same or different. These two may be same or these two may be different. Okay. In water, which type of hydrogen bonding is present? Inter. In ammonia, inter. In HF, inter. In CH4, no hydrogen bonding. CH4, not possible. Examples list is very important. Several times examples came in the exam. Okay. I'll give the list separately. Okay. After completing the definition. Intramolecular. Intramolecular. See, before that, what we took two molecules, one, maybe same or different. Now, what I am doing, I removed one molecule. I took only one molecule. Only one molecule. There is no another molecule. This another molecule will be similar to this or different to this. But in second category, what I am doing, I am removing another molecule. I am taking only one molecule. One molecule. For example, imagine this is one molecule. This is one molecule. Here hydrogen is present. Here oxygen is present. This single molecule only. Single molecule only. In that single molecule, in one place hydrogen is present. In another place, more electronegative atom is present within the same molecule. This is hydrogen. This is more electronegative. Between these two, hydrogen bonding takes place within the single molecule. Hydrogen will be present and oxygen will be present. Okay. If hydrogen bonding takes place within the single molecule, in the last case, hydrogen is present in other molecule, oxygen is present in another molecule. That is called inter. But second category, you are taking only one molecule. This is one molecule with 5 atoms. One of the atom is hydrogen, one of the atom is oxygen. Between these two, if hydrogen bonding takes place, that is called as intramolecular hydrogen bonding. Hydrogen bonding takes place within single molecule. Look at this. This single molecule. What is its name? Orthonitrophenol. This is orthonitrophenol. Just I wrote in the expanded form. Orthonitrophenol. Orthonitrophenol. This is one molecule only. You are dealing with one molecule. This is one. No other second molecule. You removed second. Only one molecule. Within the single molecule, hydrogen bonding is present. Okay. So remember, intramolecular hydrogen bonding will take place in ortho-disubstituted benzene when condition is satisfied. What is the condition? Basic condition. Hydrogen should be present on the more electronegative atom. That is the basic condition. But remember, if I ask you to give intramolecular example, what you have to take? Ortho-disubstituted benzene. Ortho-disubstituted benzene. Let us cover Examples and some other additional information. After hydrogen bonding, one ring is forming. In that ring, how many atoms also present? That is next level. Okay. Let us start the examples. Important examples. Intermolecular. Intermolecular H bonding. Intramolecular. Para disubstituted. Para disubstituted. Benzene. So whenever you observe para nitrophenol, para fluorophenol, that comes under intermolecular, para disubstituted. Intramolecular, ortho disubstituted, O disubstituted. Ortho disubstituted benzene. Okay. Say examples for this. Para nitrophenol, para nitrophenol, para fluorophenol, para. Para hydroxybenzoic acid, all para. Para position hydroxy group is there, para hydroxybenzoic acid. Okay. Ortho disubstituted means take these in the ortho position, NO2 in ortho, fluorine in ortho, OH in ortho. Same example here only, but we change the position of the substituent. Ortho nitrophenol, para fluorophenol, para hydroxybenzoic acid. What is para hydroxybenzoic acid name? What is para hydroxybenzoic acid name? What is the common name of para hydroxybenzoic acid? Online students, are you listening? Very good. Kalman. Very important. See, if you get a ortho hydroxybenzoic acid, every student can identify. In ortho, substituted benzene, intramolecular hydrogen bonding is present. Every student can identify. If you get common name, in which of the following intramolecular hydrogen bonding is present? Option A, salicylic acid. Option B, picric acid, like that. If you get, then so write general names. Already I given in the nomenclature. Better to write examples with their general names. But picric acid also important example. Okay, picric acid very important example. Once again write that and write common name. See, we'll use questions due to these small reasons. You know everything, concept about hydrogen bonding. But if you don't know the common name is salicylic acid. Where don't neglect this common name, salicylic acid. What is picric acid, girls? What is picric acid? 2,4,6 trinitro. 2,4,6 trinitrophenol, commonly called as picric acid. Picric acid. 2,4,6 trinitrophenol, commonly called as picric acid. And for them, names are common only. This is direct orthonitrophenol, orthofluorophenol, no problem. But salicylic acid, picric acid. And one more example. If you are able to remember, then remember. But these two are very important. Salicylic acid, picric acid examples. I am giving one other example to you. Anybody? Anybody? If two C in the nomenclature I taught. If two COOH groups are present adjacent position. Phthalic acid. Phthalic acid. Phthalic acid is contains COOH groups in ortho position. Phthalic acid. In phthalic acid also intramolecular hydrogen bonding is present. Catechol. If two OH groups are present side by side, that is called catechol. Next example. Write all these examples. In general organic chemistry, we discussed acidic nature of carboxylic acid. There I given the structure. What is its name? If two COH groups are present on the same side, same M, I given like this only. Code same M, malic acid. Malic acid. Right opposite side. This side. This side. What we are writing? What we are writing? Inter. What is its name? Fumaric acid. In fumaric acid, intermolecular hydrogen bonding is present. Very, very important. Fumaric acid. Malic acid contains intramolecular because two COOH groups are present on the same side. So, within the single molecule, hydrogen bonding takes place because of adjacent positions, side by side positions. Malic acid contains some statement type questions also will come. Malic acid contains intermolecular hydrogen bonding. Fumaric acid contains intramolecular. Which of the following statement is true? Like that. Statement type question. Okay. So we completed examples, important examples of intramolecular. Here I wrote a para. Along with para, see, write all this along with para. Some other examples. Already one example is given, fumaric acid. Along with that, this is one category example. See, H2O, NH3, HF, ethanol, methanol, all these are examples of inter intermolecular. One simple example. See, take water. Take one glass water. In one glass water, so many water molecules are present or not? Here one water molecule. Here one water molecule. Between the two, hydrogen molecule. Take alcohol liquid. Here one alcohol molecule. Here one alcohol molecule. Between the two, hydrogen molecule. Intermolecular. Similarly, HF also, NH3 also. All these comes under intermolecular hydrogen bonding. Very simple. One trick. Intra means ortho. Intra means ortho. And one more example, malic acid. But in general, intra means ortho. Inter means para. Inter means para. Along with that, some additional example. Okay. Now, let us see the chelation. Chelation means ring formation. Number of atoms in that ring are chelate. If our fate is not good, then we will get these type of questions. Extension means some additional information on each value. You also keep like that only additional. Additional means that depends upon your wish. Take orthonitrophenol. Orthonitrophenol. Because of intramolecular hydrogen bonding, chelation takes place, ring formation takes place. In that ring, how many atoms are present? New ring. How many atoms are present? Online students. Hydrogen, oxygen, carbon, nitrogen. Count all. Six. So 6-member ring. 1, 2, 3, 4, 5, 6. 6-member chelation. 6-member. Here, oh, sorry, with hydrogen I have to write. Here, hydrogen, oxygen, carbon, how many? Seven. Seven. Additional information. Okay. Finally, consequences of hydrogen bonding. Very important. Orthonitrophenol, paranitrophenol, which is more volatile, which is having more boiling point, which is soluble in water. Most important table we are going to discuss. Right, consequences of hydrogen bonding. Consequences of hydrogen bond. We are comparing the physical properties of orthonitrophenol and paranitrophenol. Because of hydrogen bonding, physical properties will change. This is also theoretical question came in the JEE means. Consequences of hydrogen bonding. First, comparing the physical properties of orthonitrophenol and paranitrophenol. O-nitrophenol, orthonitrophenol, and paranitrophenol, P-nitrophenol, paranitrophenol. Okay, see. Here, which type of hydrogen bonding is present? Tell me. In orthonitrophenol, intra or inter? Inter or intra? Intra. 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 Ortho means intra. Para means inter. Intramolecular. Intramolecular H bonding is present in orthonitrophenol. See, when intramolecular hydrogen bonding is present, see, it will get some special physical properties. Okay, what are the special physical properties? It is having, these are very important point, less, having less boiling point, more volatile, very important point. If boiling point is less, volatility is more. Best example, take water and petrol, keep on the table. Water and petrol, which is more volatile, petrol or water? Petrol is more volatile and having less boiling point. Petrol boiling point is less. You no need to boil. You no need to heat. Itself only undergo evaporation. If boiling point is less means volatility is more. For example, water boiling point is very high, 100 degrees centigrade, it boils. If the boiling point is more, so volatility is less. Clear? Less boiling point means more volatile. Just you remember water. Take general example. If you get any confusion in remembering this, what you have to do, imagine water. In general, we heat water in the kitchen, right? Water boiling point is 100 degrees centigrade, means more boiling point now, so it is less volatile. If you keep water there, 1 liter water, so many days after so many time it will evaporate, right? Clear? Hmm. Next, solubility. These three are very important. Solubility, boiling point, volatility. Less soluble in water. Less soluble in water. The compound in which intramolecular hydrogen bonding is present, which is less soluble in water. Less soluble in water. Over. Finished. Here, right opposite. Right opposite. Water opposite is intermolecular. Intermolecular H bonding. Right opposite having high boiling point. Opposite words. High boiling point. Hmm. Less volatile, less volatile. Next, more soluble in water. Opposite, more soluble in water. See how questions came. Orthonitrophenol is more volatile due to which reason? Due to intramolecular hydrogen bond. That are only, this point only is the reason for these three. Why orthonitrophenol is less soluble in water? Due to intramolecular hydrogen bond. Okay, very important difference. Okay, we will cover remaining tomorrow.